An earthquake is the movement of the crust, accompanied with noticeable shaking of the ground. This movement happens along a fracture in the ground called a fault, where sections of the ground slide past each other. They can slide side by side horizontally. They can go up and down as well. The intensity of an earthquake is called magnitude, and the footage you see here is of a very high magnitude earthquake. The scale is called a Richter scale and was put together by Charles Richter. A 1 on the Richter scale is going to be a very minor earthquake, and as you go up the scale, it's going to be more and more intense. Ocean waves transfer energy usually from the wind, but when energy from an earthquake hits, the wave becomes much larger, and when it comes ashore, it can be devastating as well. The energy released from an earthquake is called a seismic wave and is recorded on this device called a seismograph. Pay attention to the device and you'll see those squiggly lines. Those are your seismographs on a digital device. The original seismographs was a manual device that had a roll of paper that would shake with the ground. A stable pen would draw lines on the paper showing us the intensity of the earthquake. As you will see, the wave comes in two parts. First, a smaller quick wave, and then a longer, larger wave. The first wave that is recorded is called a primary wave, and the second one is called a secondary wave.
A P wave is similar to a wave traveling through a spring. The coils compress and expand in the direction the wave is traveling. An S wave is similar to a wave traveling along a piece of rope. The wave moves along the rope by moving a section of the rope up, then down.
In this footage you will see how the earthquake wave causes the land to go up and down. Primary waves are faster and they arrive first, and they can travel through any material. Secondary waves will come, well, second, and when they travel through the Earth's interior, they cannot travel through liquid rock. Seismographs are set up at different stations, and based on their distance and the time difference between the P and S wave, we can figure out how far away it is. For example, an earthquake that takes place 2,000 kilometers away, the P wave will arrive 4 minutes after the earthquake happened, and the S wave will arrive 7 minutes and 20 seconds later. The time difference between the two waves is 3 minutes and 20 seconds. If we are just given the amount of time that is the difference between the P and S wave, we can take a look at this chart and go back down and see the distance. P waves travel faster than S waves and can travel through any sort of material. However, when the energy from the P wave goes through the Earth's interior, it's going to refract or bend when it gets to rock that is different densities. This was the first clue that there are different layers and different densities in Earth's interior. S waves cannot travel through liquid rock, and scientists noticed that S waves stopped at 2,900 kilometers, which indicated that at this layer, the Earth's interior was liquid. This created shadow zones, areas that didn't receive P waves because of the refraction, and areas that don't receive S waves because they are on the other side of the Earth, and the S waves cannot go through the liquid part of Earth's interior. Based on the actions of P and S waves through Earth's interior, scientists were able to discover that Earth has different layers, but more on that another time. For today, all you need to know is the difference between the P and S waves. P waves can travel through any material, while S waves cannot travel through liquid. Please answer the questions below. Thanks so much for watching. Have a great day.